Hello everyone and welcome back to lecture 8 part 2. So in this part of the lecture we are going to continue to talk about heat exchanger design, and here we are going to consider reboilers and vaporizers. So just like before, like condensers, we are going to talk about different types or the basic forms of reboilers and what are some of the design considerations when we are talking about reboilers in terms of applications. And also, if you are provided the necessary data and the equations for boiling heat transfer, can you design reboilers in different scenarios? Okay, so let's look at some of that. So as I said before, reboilers and condensers are very important, especially for distillation columns. So wherever you have a distillation column, you must have a reboiler and a condenser. And these reboilers are very important because when you apply it with a distillation column, so the liquid from the distillation column enters the reboiler and it vaporizes the liquid, and then by doing that, it maintains a certain vapor fraction inside the distillation column. Okay. You can have also other applications of reboilers using based on the same principle. So, for example, you have a reactor that required a vaporized reactant, for example. So you can use the reboilers to where the liquid enters the reboiler and then it vaporizes the reactant, and then the vaporized form of reactants enter the reactor. Okay, but again, as I said, it follows the same principle as distillation. So the discussion that we are going to have in this lecture is mostly based around reboiling for a distillation column, but exactly the same procedure or same principles can be applied for reboiler connected with any other equipment. And the consideration of design of reboiler is going to be really important for you guys in the design project in year 3, where most often you have processes that require distillation columns, and distillation columns always come um, with reboilers. So from today's lecture, it is really important that you pay attention on the operation of these reboilers and what considerations we make when we talk about design of reboilers. Okay. Now let's have a look at some of the most common reboilers and vaporizers. So one of the common reboilers is what we call kettle reboiler. Okay, so this is how it looks like. So here you have a distillation column that is attached with a kettle reboiler, where you have a number of tubes here inside a big shell, and the hot fluid enters the tube side and then leaves from the bottom, while the liquid that is coming from the bottom of distillation column comes in this shell, and then due to this hot tubes, it actually vaporizes and then goes back to the distillation column to maintain a value of vapor fraction here. So these kettle reboilers are very common in chemical engineering. In almost all distillation columns, you will see these kettle reboilers. And the reason they are called kettle reboilers because they look or they work on a similar principle as your boiling kettle, where you have this heating element that actually heats up the liquid here and then it vaporizes and then it enters to the distillation column. So these kettle reboilers are very reliable and easy to maintain. As I said, that you just have a heating element here, so in case if there is a problem, you can remove this heating element and replace it with another set of tube bundle. So it is easy to maintain and quite reliable. On the other hand, they are very expensive and easy to foul. Sorry. The reason they are quite easy to foul is because just like your kettle, for example, you normally see that there is a lot of limescale on the kettle heating element. So similarly here, because it is heating an unpure product, and very often you have limescale or some sort of fouling on the tube surface that reduce the heat transfer. And they are quite expensive because it requires quite a large shell, because when you are vaporizing the liquid, it needs a lot of space above it, and that's why the shell is quite large, and as such they are quite expensive. And here are the points that I just discussed with you. Now, another type of reboiler is what we call Thermosiphon Reboiler, and this is how it looks like. So it is, again, it is attached with a distillation column, and here you have a shell and tube configuration where the tubes contain the hot fluid, and then again the vapors, the liquid from the bottom of distillation column enter the shell of this reboiler, and then the tube fluid vaporize it and it goes back to the distillation column. And here if you see that there is no large shell available, okay, and the tubes are just heating the liquid that enters from the bottom and then vaporizes and it goes up. And because there is no large shell available here, these reboilers can only work with where you only need a small fraction of vaporization, like 20 to 30% of the liquid entering the system, okay. And as such, the stream that is leaving the reboiler contain a mixture of vapors and liquid, and then it enters the distillation column where this plate here separates. Vapors go up while the liquid again settles down and then circulates in this reboiler. And the reason these reboilers are called thermosiphon, because they use a form of natural circulation by utilizing the difference in density between the liquid that is entering the system and the outlet vapors and liquid that is exiting the system. And that provides this reboiler the necessary head to circulate the column liquid from here to the reboiler, and as such we don't really require any pump here. And here the vaporization is happening in the shell side of the reboiler. And then you have what we call vertical thermosiphon reboilers, and the main difference is that in this we have the hot fluid in the shell while the vaporization is happening inside the tube, okay. And most of the time these thermosiphon reboilers are one-to-one heat exchangers. It means that they normally do not have multi-pass. They have just one-to-one, one tube and one shell pass. So here I have put some journal information about thermosiphon reboilers. So thermosiphon reboilers have the disadvantage, if you compare it with kettle reboilers, that you cannot consider the thermosiphon reboiler as one theoretical stage of distillation, because we do not attain a vapor liquid equilibrium inside this reboiler. The advantage of thermosiphon reboilers are because they do not require very high degree of vaporization. As such, they have less fouling potential compared to a kettle reboiler. Okay, but they do foul, especially when you increase the degree of vaporization to 80%. Then you have excessive fouling on the reboiler. But normally, thermosiphon reboilers are used in the degree of vaporization range of 20 to 40%. Okay, and for the case of thermosiphon reboilers, there is a very important characteristic parameter that what we call recirculation ratio. So recirculation ratio defines to what extent we are producing vapors from a liquid entering the system. Okay, and this circulation ratio is normally in the value range of 0.25 to 6, and it can be defined as the ratio of the flow rate of the liquid at the reboiler outlet divided by the flow rate of the vapor at the reboiler outlet. Okay, so if you compare how much vapor you are generating in a stream at the outlet of the boiler, you can calculate what is the circulation ratio. Now, if you compare kettle reboiler with thermosiphon reboilers, generally for the case of if we compare the rate of heat transfer per unit area and the heat transfer coefficients, we can see that the vertical thermosiphon reboilers are one of the most common designs used in industry compared to horizontal thermosiphon reboilers and kettle reboilers, because they give you much higher rate of heat transfer and heat transfer coefficients of the system.